Amines are pretty reactive substances. We'll talk about 6 reactions that amines like to undergo. Amines are organic bases, and when it comes to amino acids in a later chapter, well, they have that amino group. And amino acids, as you know, are the building blocks of proteins. So the reactions that we're going to talk about here lay the foundation for protein chemistry. Well, if amines are organic bases, that means that they're most likely soluble in water if they're low molecular weight, and they're going to interact with that water molecule. If the nitrogen is basic, the proton from water is going to protonate the nitrogen. We get a positive charge in CH3 and H3+, and left behind is the OH-, or in addition is the OH-. If we were to test this reaction with pH paper, we'd find that it's basic because of the presence of that OH- ion and because of the presence of the nitrogen too. Again, I think we remember reactions in words. I don't think our mind works in structures, so it's nice to identify these reactions with words. An amine plus water gives us the structure over here. The second reaction also takes advantage of the fact that amines are bases. If they can react with water, surely they can react with an acid. So here we've got an amine plus hydrochloric acid. The proton from the acid is going to attach to the nitrogen, and we get CH3, NH3+, Cl-. And when we have a plus and a minus, that reminds us of the inorganic compounds. We can call this a salt. It's an amine salt. Let's look at reaction number 3. Amine salts, the product of an acid and an amine reaction, can be reversed. We can get the amine back from them by adding a stronger base. So sodium and hydroxide and the amine are now competing for that proton. Sodium hydroxide's a lot stronger base. It's going to take the proton back from the amine, form sodium chloride, and we have the amine back. In reaction number 4, we're talking about amide formation. And here's the amide functional group. It's a C double bond O with a nitrogen next door. Amides are very important substances because proteins are amides. They're polyamides. To form an amide, we need a reactive substance like this acid chloride. You can think of it as a carboxylic acid. We've traded the OH for a Cl to get this acid chloride. It's a much more reactive substance. It can react with amines. And what happens is one of the hydrogens from the amine and the Cl form HCl. The nitrogen is now bonded to the C double bond O. As this occurs, then we have this amide structure. Let's look at reaction number 5. With this many reactions, it's nice in your review to have them all on one sheet of paper so that you can compare and work out quiz and exam questions. It's also, these reactions are summarized at the end of the chapter in key equations. These two, 5 and 6, deal with the hydrolysis of amides. And again, it's an important topic because proteins can be hydrolyzed within the body. Here's an amide. If we put the amide under acidic conditions, water and an acid, have to apply some heat because this amide linkage right here is pretty strong. And we want it to be strong because that's what holds proteins together. The product, if we break that linkage, we get back the carboxylic acid, and under acidic conditions, we get not the amine, but the amine salt. Under basic conditions, we won't get an amine salt, we get something else. Again, this bond is going to be broken. The amide will be cleaved, we get the carboxylic acid, and under basic conditions, you know that the carboxylic acid forms a salt. and the free amine. So those are our 6 reactions. What now if you were to face a quiz question or an exam question that deals with reactions? Let's just practice one of those. If I were to see something like this on a quiz or an exam, this is the thought process that I'd go through. I'd say, hey, it's a reaction question. Then I'd look for a functional group so that I know which chapter it's dealing with. And I see that nitrogen. So I'd say, hey, it's one of the nitrogen reactions. I have 6 of those. And I'd look on my sheet, or I'd go to the end of the chapter where the reactions are summarized, and I'd see which of these conditions, or I'd narrow it down by looking at the conditions, I should say. I see hydrochloric acid, so in words, we're reacting an amine with an acid, and this reminds me of reaction number 3. We're going to get an amine salt as the product.